according to quantum linearity. So quantum linearity tells us that we could produce cats which are in superpositions of life and death. Well, sometimes if I'm in a bit of a hurry, I stop at this point. You're saying, isn't this ridiculous? And Schrodinger was saying this to show that it was ridiculous. And Schrodinger, it's fine for him to say that because it was his equation after all. And he was more or less saying, don't believe my equation when it's applied to cats. Well, that's fine. But sometimes when I give this, my colleagues say, no, you've been a bit sloppy here. You haven't taken into account the environment. So, well, for this lecture, I especially wanted to make sure I did that. So here we have, I think the dead cat, just not that it makes much difference. Here we have the poor dead cat, and it has to have an environment as well. Okay, so there I put it there. Now what about the live cat? Well, okay, the live cat, sorry, yes, the live cat, it needs its environment too, so here it is. Now you may not notice much difference. I assure you that those little particles, air particles, are in different places. And just so you know they're different, I've done them in a slightly different color, but that's just to help you. They're not really a different color. They're meant to be the same color as the environment spots in the other picture. And what does quantum linearity say? It says that you get this. Not just the cat being in a superposition of life and death, but all those environmental particles being in superpositions of different places too. Doesn't seem to help very much, does it? Well, the official thing you're supposed to do is worry that you don't know where the environment is, and so you do some process called summing over the unknown states and so on. Well, it doesn't, you can do that if you like, but it doesn't really help, because you're supposed to have some state, even if you don't know what it is, there should be some state that the system has. Okay, it may not be that's the whole issue then. Suppose somebody comes along. Let's go back to the dead cat again. I think that was the first one. Okay. I'm getting very complicated with all these. Here's the dead cat. Somebody might come along and look at the cat, you see here. So I have an observer coming along. Maybe that's the key thing. An observer comes along, looks at the cat, and I've got even represented part of the state of mind of the observer, which is the observer seems to perceive a dead cat. So we could, perhaps this is part of the quantum state too. You don't have to know what the observer's mind is registering, you just have to look at the observer's expression. You see there's a rather grumpy looking face there, whereas in the case of the live cat, well, yes, the observer comes along and looks at it. There we have the cat. And you'll notice that the observer is rather happier in this case. So, okay, there is a bit of difference. Needn't be huge. But the thing is, what does quantum mechanics say? Well, the observer is only made of material and all that sort of stuff, quantum particles and so on. So that observer ought to be involved in the superposition too. So this is the description that one is led to. I can get these things properly on top of each other, I hope, with a somewhat mixed expression and a certain mixed perception. It doesn't really help. What about you? You could put the environment in as well if you like. Here it goes. I mean, none of these things really make any difference. Well, you could say that, and people do, and this is the many worlds interpretation of quantum mechanics, which says that, indeed, the observer would be put into a superposition, but that kind of observer perception is not allowed for some reason, and the observer state splits, and they become two universes, one containing one observer and the other containing the other observer. Well, there's nothing in this which splits, I should say. It really is a superposition still, even if you believe it applies to the whole universe. Now, it is a view which is very often expressed about quantum mechanics, and it's called the many worlds view, which says that somehow this is what happens, and it's supposed to make sense of it. Well, the idea is, I suppose, that for some reason, perception states, whatever they are, aren't allowed to be this, and you're allowed to perceive one or the other. And it's not explained why perception states have to have that form. What I particularly don't like about the many worlds approach, I can see you're forced into it. You see, if you believe that U holds at all levels, you are driven to this view. So this is where quantum mechanics takes you, if you like. Or it does if you believe that it's a consistent theory in which U is the only thing happens, unitary evolution. And the resolution, according to many worlds, is that somehow you have to understand that perception doesn't do this and it singles out one of these universes. It's conceivable that that is, in a sense, correct. The trouble is, it seems to me, that you're pushing your very precise physics. It's one of the things about physics. And all these rules that one's applying, they're very, very accurate, extraordinarily precise. And you're pushing it into an area that we know absolutely nothing about. We don't know anything, very little about consciousness, what it is, and why one should get the probabilities of quantum mechanics out of this thing that we know nothing about. So it's conceivable it's the right answer, but it would be a sad thing if it were, because we'd have to know a lot more about things that we're further from understanding than we are about quantum mechanics. So let's... I would take the view that this is virtually reductio ad absurdum. As